ladies and gentlemen. In this video, I tell you about encoders. So in the last classes, you familiarized a circuit called decoder. You have seen 2 to 4 decoder and 3 to 8 line decoders. Now this is another this is a reverse operation called encoding. Let me start with that presentation. So the speech is organized in your learning outcomes, then the design of a 4 to 2 encoder, then the design of an 8 to 3 line encoder, and the summary of understanding. So what you will learn in this video, you will learn the operation of a 4 to 2 encoder and implement it in QUCS. Then you will learn to implement an 8 to 3 encoder in QUCS. So the block diagram of a 4 to 2 encoder is like this. There are 4 input lines. One of it is high at a time. Okay, either I0 is high or I1 is high, I2. No two ones can occur at the inputs. It's just like this push button switches. Only one of it is activated at a time. I0, I1, I2 or I3. And based on that, the 2-bit patterns Y0, Y1 comes out. Now this Y0, Y1, they follow the pattern 0, 0, 0, 1, 1, 0, 1, 1 for the input patterns. I0, 1, 0, 0, 0. Only one of the inputs is high at a time. Or 0, 1, 0, 0, then the output is 0, 1, and 0, 0, 1, 0, it is 1, 0, and 0, 0, 0, 1, 1, 1. Okay. Here Y0 is the MSB and Y1 is the LSB. Now this Y0 can be easily designed, as you can see, that is 1 for these two cases, that is I2 is 1 and I3 equal to 1, so Y0 is I2 or I3. And Y1 is I1 or I3, I1 or I3. When one of the inputs I1 or I3 is high, then Y1 is high, I1 or I3. This is a very simple design. Now you can see the circuit diagram. Now these are the input lines I0, I1, I2, I3. This may be connected to push button switches or pattern generators or something like that. And you have these two OR gates realize my 4 to 2 encoder. Now you can see the simulation in QUCS. You can see the circuit here. What I have done is these OR gates are here, 2 OR gates are here. Now this I0, I1, I2, I3, they are connected to 4 sources. So each source is high at a one instant of time. Say this is high for 1 nanosecond and low for 10 nanoseconds, and this one, second one, this is initially low for 1 nanosecond, then for 1 nanosecond it is high, and remaining time it is low. And this one, this is for the first 2 nanoseconds it is low, then for 1 nanosecond it is high, and for the remaining time it is low. And this one, this is initially high for 3 nanoseconds, low for 3 nanoseconds, and then high for 1 nanosecond, then for the remaining time it is low. Now this realizes my input pattern. These 4 sources realize my input patterns. Now let me go to, now I have dropped a digital simulation with for 10 nanoseconds and a very log model. Now I run the simulation, and you can see that you can see these waveforms. This I0, I1 is a 1, 0, 0 pattern, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1 that way. This is how I realize my I0, I1, I2, I3 with my sources. And you can see here this this one, you can see that this is agreement with our the tutorial we proposed. I1 0 0 0 it is 0 0, and 0 1 0 0 0 1, and 0 0 1 0 it is 1 0, 0 0 0 1 1 1 that way. Okay, so this is how I verify the verify the operation of a 4 to 2 encoder using QUCS. Now let me go back to my presentation. Now what about the design of an 8 to 3 encoder? Now there should have 8 lines, one of it is high at a time. So I have 1 0 0 0 etc. Here Y0, Y1, Y2 with Y0 as a LSB and Y2 as a Y0 as a MSB and Y2 as a LSB. Only I wrote like that, 0 0 0 0 0 1 that way. So diagonally, if you say the ones come this way. Now this design of the circuit is very simple. This is just an extension of the previous 4 to 2 encoder. Now this Y0 is high for the last 4 cases, so it is I4 or I5 or I6 or I7, and here this y0 is I4 or I5 or I6 or I7. That is where it becomes 1. And for I1, so that is this equation I4 or I5 or I6 or I7, equation number 2a. And this y1 is nothing but that is I2 or I3 or I5 or I7, I2 or I3 or I6 or I7. And y3, this is one for alternate values, that is starting from I1 or I3 or I5 or I7, I1 or I3 or I5 or I7. That is equation 2c. Now you can, this is how I realize the circuit. These are the input lines I0, I1 to I7, and these are my OR gate outputs Y0, Y1, Y2, with Y0 as the MSB and Y2 as the LSB. Now I can realize this in QUCS this way. I will close this. I will open the second one. These are my OR gates. Now here also I have selected the source in such a way that it remains high for 1 nanosecond. Only one source is high at a time. You can see that initially it is high for 1 nanosecond and low for 10 nanosecond. The next one is initially it is low for 1 nanosecond, then high for 1 nanosecond. For the remaining time it is high. If you go to the last one, it is for 7 nanosecond it remains low, then it remains a high. For the remaining time it remains low. So this is I run a digital simulation on this with a Verilog model and a time list for 10 nanoseconds. If I run the simulation, you can see that you get the truth table this way. I0, I1, I2, I3, you can see that is 1 0 0 0 etc. It is 0 0 0 0 0 1 0 1 0 0 1 1. You can see that the ones are moving like this. Only one high is there at a time. You can see that this is following the said truth table. Now this is how I design and implement an 8 to 3 encoder using QUCS. Now let me go back to my presentation. Now what you have understood in this video are that you learned the operation of 4 to 2 encoder and you implemented it in QUCS. Then you designed and implemented an 8 to 3 encoder in QUCS. And that is the end of this presentation. I thank you.